So very warm welcome once again to my YouTube channel Simulation Engineer. Today the topic of my video is descriptive statistics. It's part 2. So we will be doing today pivot tables alternative to calculate median, also some other measure or quantities which is very important for descriptive statistics, which is like not possible using the regular pivot table options we have available using WPS Spreadsheet. So I am going to demonstrate how to calculate not only median but how you can calculate, for example, skewness, kurtosis, and some other parameters. And if you have not seen my first part for this descriptive statistics tutorial, then I would advise you guys to go to my YouTube channel, and I have a specific playlist, WPS tips and tricks, where you can find all other data analysis tutorials which are very useful. For example, like pivot table data analysis, regression analysis, you have like forecast functions, and this is the part 1, so descriptive statistics using pivot tables. So if you have not seen this part, go ahead, have a look on this part where I have shown the quantities which is really possible by using the pivot table for your data set. Okay, so what we will be coming up at the end of this video session, we will come out with some data set, and we will see how we can perform our descriptive statistics or descriptive analysis to calculate, for example, the mean values, median, skewness, kurtosis, and then you can plot things like, for example, comparison between median and average, or skewness and kurtosis. So I think this will be very helpful for those guys who do not have an option of using like other tools which you have to pay for some packages. For example, there are options available in Microsoft Office. So in Microsoft Excel, there is an option for power pivot, not in regular pivots, but you can plug in or embed some advanced pivot options, and then you can get all these measures like median, skewness, kurtosis. But if you do not have an option or availability of such features, of such tools, how you can do that alternatively in a normal Excel sheet or a WPS spreadsheet, or it is also valid to Google Sheet. So I will today demonstrate this, how you can do this. So as mentioned earlier, so it will be descriptive statistics part 2. I am going to repeat some of the things which I have done in the first tutorial. So the descriptive statistics consist of several types of measures. If you have a sample data, there are different kinds of measures. So the first one is like central tendency, which provides you the centers of the data, which is dealing with the central part and the central trends of your data. And these quantities are like mean, median, and mode. And also there is another term which is known as like variability, which will be telling you about the spreadness or scatteredness of your sample data, and these quantities include like standard deviation, you have variance, and etc. Then a very important aspect is like to see if your data is really symmetric or not. So this can be judged or identified using skewness and also kurtosis. So the observation here will be like by using skewness or kurtosis, you will be getting the relationship between your mean and median measures or quantities. How you normally can do that, for example, in really regular pivot table, there is not option available to compute median, skewness, or kurtosis functions. So the workaround is possible around the pivot table. So the hint will be like you can calculate all the default or the possible quantities using the pivot table. And normally when you use or when do you normally use medians to analyze data, one has to take into account that the use of average or the mean values or the mean measure is really very helpful to identify your central portion of your sampling data or to the central behavior of your data. But sometimes this average or mean values can be really misleading, because in those cases where your sampling data is not really fully symmetric, meaning if the skewness is not zero, if it is non-zero, so it could be positively skewed or negatively skewed, or in another term, if the data is really highly skewed, then you must get hold of your median values. So the measure of median or the use of median is very important in those cases. So how you can check here that your data is really symmetric or if it is skewed or not? Then, for example, in how you can calculate the skewness for your sample. If let's say we have a skewness of a sample which is used as a measure of symmetry. So if your skewness is 0, then the distribution is fully symmetric. Yeah, and then in that case the average or the mean measure is I would say in most of the cases is good enough. But if there is a slight variation and you have asymmetry in your sampling data, then you have to go and measure the skewness. So why not? It's a good practice that one should really make a kind of a default practice and always determine these measures to be on the safe side. So positive skewness indicates that that your data is moving or tending towards the positive values, and vice versa, like negative tends towards the negative values. This is the formula to calculate the skewness. So where in this formula you can see this x bar, it is your mean value, s is the standard deviation for your samples, and in order to avoid division by 0, so you don't want to get any infinite numbers or something like this, so you don't get any error, we can see in the denominator of this formula that n minus 2, so it has to be minimum starting value should be like 3. So that formula requires a number of samples has to be minimum 3. So in terms of skewness and symmetry, so when the distribution is really symmetric, in that case s is 0, then that means mean is equals to median, or the average value is equals to your median. If it is positively skewed, then the average value will be greater than median, and when the distribution is negatively skewed, then the mean or the average value is less than the median. Then another important measure or quantity is like kurtosis. It is if you wanted to take or calculate kurtosis of your sample like S, it will be giving you the information about let's say the endpoints of your data distribution, or you can call it the extremities. So it's not concentrated to the central part, because it has nothing to do with your central tendency. It's like more towards the extremities of your data points. So that means, in other words, it is giving you an information of about the outliers. So this is the formula which is used to calculate kurtosis. And once again, as seen in case of the skewness definition, x bar is the mean value, s is your standard deviation of your sample data. So again here, in order to avoid divisions by 0, this formula requires, or this equation requires, that your number of samples has to be greater than 3. So that meaning that it should start from n equals to 4, so that you will get 4 minus 3, for example, it's 1. If it's 3 minus 3, it's 0, you will get infinite number. It's an error. So before wasting further time, we have seen just a brief description how these quantities can be measured. What are these quantities which you cannot unfortunately calculate in pivot table, in regular pivot tables. So I will show you a workaround how you can do that. So let's move on to the practice session. Alright, as we can see in our WPS spreadsheet, we have two columns, column A and B. The column A consists of labels. So we have several labels which are repeating after several times, and we have a sampling data with specific number values. And what we will be doing here is that I will be generating a pivot table for this data set, and I will show you how you can generate some standard measures, and based on these measures how we can generate the other very important measures like median and skewness, kurtosis, based on our pivot table. So let's start. So you just select your data set, and then you go to insert and say pivot table, and I'm happy with this selection range. That's it. So I'm using existing worksheet. I would like to place my data or pivot table in this section. So then you simply say OK. Once you say OK, so it is showing you pivot table to build a report or choose fields from the pivot table field list. So we have now two field list available, label and sampling data. So I will move label to the rows. So I wanted to plot these labels AA, BB, CC, DD against the sampling data. So I will move it to the values section. Let's say it is a default, so I don't want to calculate the values for my descriptive statistics. I don't want to get the value of sum. I will start, for example, first of all with standard deviation. So also another tip, you can also customize your name, so you can make it a little bit shorter. So I would say it's standard deviation. So this is the standard deviation, and then you drag once again the sampling data into the values section. So then we could calculate, for example, the variance. So you remove that, customize your name. I will write it here, for example, variance. So let's say we have now two values available. We are able to calculate the standard deviation, variance, and there are lots of other parameters which we can calculate using the pivot table descriptive statistics options. In total, you can these are the options which you will be able to calculate from your sampling data. But as you can see, unfortunately, in regular pivot table, the median, skewness, and kurtosis are not available. So these are the options which will be calculating. These are the measures by using some workaround. And let's say the last entity, I will call it average. So it's either it's average or mean. It's you can rename it to mean values, and we will get our mean here. So we are not interested in any grand total or the summation. So let's remove the grand totals. All right. So let's make this a little bit bigger, this section. So you can, let's make it 15. All right. Now we can see that quite well. So we have calculated standard deviation, variance, and mean. So we have seen there are also several other parameters how we can calculate. So for this session, I think I'm satisfied with these parameters. I've shown you how you can calculate the available measures using the regular pivot table. For example, I am now interested in calculating the median. So I will simply write it here, median, and I do the same formatting as in case of these. So you can do the formatting from this way. So if you say format painter, you go to this section and you say median. So you can again say skewness, right? So also you could say kurtosis. So all these options which are available, you can do this. Now comes the interesting part. So the tip here is we'll be using a median with a combination of if function to calculate median based on our pivot tables. So we will say median, and the moment you write median in the formula bar, so it returns the median of your given number. So I will say median. Then you start with your round bracket, and now I'll be using if function. I will say if the values, so it will be a logical test. So the logical test will be if these labels in column A are equal to this label in our pivot table, yeah, and make sure to make these values of column A absolute value, so it has to be fixed, so they should not change, because we will be calculating later on for label B, C, and D. So I'll be fixing these values. I'll remain this value D4 in the column D4, which is this one, as a variable, so it's not fixed. So I will say the function or the formula if function should perform this test. So if this column entries are equal to D4, then comma, so true value if true. So the true value will be that it will go into column B and search for the values which are equal to the label A. So give me these values. So again, I will make this an absolute value. So I will fix this in the B columns. Okay, so then you will say comma value if false, so nothing, do nothing in case it is false. Then you close the bracket, and now we will use Control plus Shift plus Enter key combination to execute this formula. So we have a value of 63. Now keeping this cell selected, you have this on the lower bottom right, this small handle, this green one you dot, you see, and you got this crosshair. Once you move your mouse over this small handle button and you drag it down, and we see we have now the median for all our 4 sample data, so label A, B, C and D. And we'll use the same approach for skewness. I will demonstrate once again. So we will say skew, so I will type skew here and say returns the skewness of a distribution. So it's a characterization of the degree of asymmetry of a distribution around its mean value. We have seen in our previously in our slides that I've shown you the definition and what are the different parameters or what kind of observations we can get from skewness. So we'll say skew, again we're using the if function. I will use the same approach. The number of values in the column A, you have to use once again the same procedure like absolute values. And then we will say if it is equals to the column D4. So in column D, the entry number or the row is D4. Then you move on to the next logical statement, which is value if true. We will fix once again these values. We will press once again comma, and I will say we'll leave it empty. Close the round bracket. Again use Control plus Shift plus Enter on your keyboard to execute. So we have a negative skewness in case of label A, and we use the same procedure, drag it down till your sample D part, and we say we have like BB and label CC. It's a positively skewed data, so it's total. There is, in case of all these 4 labels, there is no skewness. The data is not symmetric at all, so we don't see any value of 0, except in this value of label D, which is minus 0.3. It is closing towards 0, but still it's not 0. So this is the way you normally calculate your values. And again, you can also calculate, for example, kurtosis. So you can see it is giving you the kurtosis of a data set. So it characterizes the relative peakness or flatness of your distribution in case of with the normal distribution. So we use kurtosis, and then I'll be using the same formula. So I'll try to do it a little bit quickly, but because I think by this time you guys will have an idea how you can use this if function. Alright, we'll go with this data if it's this fixed. So I will now make them absolute. Close it. There you go. So we have our kurtosis function also now done. So this is how you normally calculate these values. Once you have calculated your pivot table, and then you can calculate all these values with this approach. And now let's have a brief look once again what this formula actually do. Okay, we have seen in our calculation of, for example, the median values earlier. What you normally do is that you use this median if statement, and we say we are going to check the logical test, the number of entries in the column A, and it's going to check for this label D4 entry, which is like AA in our case. So if it from this data for this set of arrays, if function finds the label of double A value, what it will do is it is going to give a logical truth that it will be true value. So it will be giving us the standard deviation or variance or mean or median for all these cases. So for in our case, let's say we are now calculating the median, so it will give us the value, and if it does not find anything, then it's like empty, or maybe it will give you, for example, not applicable or any errors here. And so this is kind of a small background, and this is the way it really operates, this thing. I think this is now clear to you guys how you can do this to calculate your median, skewness, kurtosis, and get a direct comparison to your mean values. Now, for example, we can also directly plot our results. It's also very easy. So if you see, we just select mean, median, and all, mean and median. If we wanted to just have a plot, let's say we're happy with this, and you can plot your result. So in this case, you can plot, for example, your standard deviation, your variance, and the mean values if you simply insert these plots in this way. But you can also, I mean, it's up to the user. You can manipulate if you say you don't want to now see the values of label C and D, so you can also squeeze it down your plots further, and then you have an options of available. So for example, we have standard deviation, variance, and mean, and these are the values available. You can also play around with this with some other values. We see at the moment you will simply disable that. It has also been filtered out even from here, so you can, once the moment you select it, you said okay, we will get our values once again. So it is now these three values like median, skewness, it's now dependent on the pivot table. So it's kind of connected to your pivot table because of our equation, our if function, which we have used. And this is the way normally you calculate your median, skewness, kurtosis, and also possible other parameters. And the trick here is that you can use the formatting to match your table. So even you can also, for example, do this and make it further nice. I'll just give you a tip. So it's looking just like the complete pivot table. So this is the way or the workaround how you can calculate that. So I think I will just now conclude our today's video session. We have seen how we can perform descriptive statistics using WPS Spreadsheet, and how we can use alternative approaches around our regular pivot table to calculate median, skewness, kurtosis, other parameters. And WPS Spreadsheet actually offers wide range of data analysis options, even with your complete free version. So with this, I will come to the end of my video today, and I would encourage you guys to please like this video and share this video. And if you have not done until now, subscribe my channel please. And I'm repeating, please like this video, because this will push my video further up, and I need you guys' support. And this video I have already made it on the request of so many followers of my side, because they have been requesting me, asking questions that how you can manipulate these different values which are not available in pivot table. So thanks a lot for your input and your feedback. So keep supporting me and keep liking my videos. And I wish you everyone a very nice day. Take care and bye bye.